In DC circuits, resistors and capacitors behave very differently. A resistor dissipates electrical energy as heat, but a capacitor stores electrical energy in an electric field between its plates. The amount it can store is measured by its capacitance given by the equation shown. When a capacitor is connected in series with a resistor and a DC source, current initially flows as the capacitor begins to charge. Over time, the voltage across the capacitor increases and the current decreases exponentially. The charging follows these two equations, where R is resistance, C is capacitance, making up the time constant, the time it takes for the capacitor to reach about 63.2% of its final voltage. Each time constant marks how quickly the capacitor charges. After one time constant, it's 63% charged. After 2, 86, and after 5, about 99%. At this point, the capacitor is effectively fully charged and behaves like an open circuit, meaning no current flows through it anymore. This is known as a steady state. If the DC supply is removed, the capacitor begins to discharge through the resistor. The voltage falls exponentially through the equation shown. This is the same process in reverse. The stored energy is released back into the circuit. Capacitors are everywhere. They smooth voltage in power supplies, provide bursts of energy in camera flashes, and block DC signals in audio circuits. So in a DC circuit, a capacitor first charges, then blocks current once steady state is reached, acting as an open circuit while storing energy in an electric field, and then ultimately discharging.